Hello, friends. Welcome to the channel where we don't just recount facts, we dig to the very core. Today, the story of one of the greatest paradoxes of World War II. A story that rewrote battle maps, decided the fates of armies, and showed how blind faith in the perfect can lead to collapse. If you love deep dives where technology, history, and human decisions intertwine into one detective story, you're in the right place. Don't switch off, it's going to be intense. And be sure to read to the end. I'm waiting for your comments there, because this topic sparks endless debate. And of course, subscribe so you don't miss our next investigations. Imagine this scene. Germany, the mid-30s, a country that for the whole world is a synonym for order, precision, and engineering genius. The birthplace of Rudolf Diesel, the man who literally turned the world of engines upside down. They have the best engineering schools in the world, cutting-edge laboratories, traditions stretching back centuries. Now let's move to the Soviet Union, a country that just 20 years earlier had survived a monstrous civil war, devastation, where industry was just getting back on its feet, often on sheer enthusiasm. Technological backwardness, not a myth but the harsh reality of those years. And then war comes, and on the battlefields, two machines, which became legends, and their hearts clash. On one side, German Tigers and Panthers with their proud names on the turrets, with the roar of powerful Maybach gasoline engines. On the other, Soviet T-34s, KVs, later ISs, with the dry, characteristic knock of the V-2 diesel. And here something incredible happens. The technologically backward Soviet Union turns out to be the bearer of an advanced, highly complex aluminum diesel, while the engineering superpower Germany fights the whole war on adapted aviation gasoline engines. Why? How did that happen? Were the German engineers really dumber? No, of course not. It's much deeper, more interesting, and more instructive. This is a story not about stupidity, but about a systemic error, about the ossification of thinking, about how doctrine and bureaucracy can defeat even the most obvious technical logic. Let's figure it out, brewing some tea or coffee. This story will be long, but I promise you won't notice how time flies. Part 1, the German choice. A logical start and fatal inertia. At the start, Germany's choice wasn't just logical, it was brilliant. Mid-30s. Tanks are new, rapidly developing technology. A compact, powerful, reliable engine is needed. And the gaze of German designers naturally falls on aviation, an area where Germany, despite the restrictions of the Treaty of Versailles, had been secretly and very successfully developing. The Maybach company was an ace in creating aircraft engines, taking a ready-made, proven design and adapting it for a tank, genius, fast, and effective. Thus, the Maybach engines for tanks were born. Let's take the pinnacle of this path, the Maybach HL 230. The numbers are impressive even now. 12 cylinders, a displacement of 23.1 liters, power up to 700 horsepower. It was a technical masterpiece. High revving with a carburetor fuel system, it gave the tank phenomenal power-to-weight ratio. Imagine the Panther or the Tiger, heavy, armored vehicles that could still develop decent speed. That's thanks to the Maybach. And here we come to a key point, the German military doctrine. The Wehrmacht thought in terms of blitzkrieg, lightning war, a strike with a high-quality, selective instrument at a weak point of the enemy, a rapid breakthrough, encirclement, defeat. The war was supposed to be short. In such a paradigm, a tank is the knight's sword, an elite, expensive, complex breakthrough tool. It doesn't need to be made by the tens of thousands. It doesn't need to be driven on 1,000-kilometer marches. It will be delivered to the battlefield on railway flat cars. It will make a swift dash, break the defense, and then it will be meticulously serviced by engineering brigades. In this logic, the Maybach was ideal. Its relatively short engine life, 300 to 350 hours ideally, was not a problem. The war was supposed to end quickly. Its demands for high-quality, high-octane gasoline, for clean cooling systems, for highly qualified maintenance, also not a problem under conditions of a short, victorious campaign. But the war with the Soviet Union stopped being a blitzkrieg. It turned into that very total war of attrition. A war of survival, where the count was not in quality strikes, but in tons of metal, millions of liters of fuel, thousands of kilometers of stretched communications. And here the Maybach began to show its downside. Part 2. Anatomy of a vulnerability. Why the Maybach suffered in Russia. Let's describe the conditions of the Eastern Front. It's dust. It's mud, turning into a sticky, impassable mass in spring and autumn. It's frost, freezing technical fluids in winter. These are huge distances that tanks often had to cover on their own. Railways destroyed, not enough flat cars. It's a chronic shortage of trained mechanics closer to the end of the war. It's deteriorating quality of materials and assembly under the blows of Allied aviation. And against this background, the Maybach HL-230 was, to put it bluntly, a delicate aristocrat. Its cast iron block, its dense layout in the cramped engine compartment of the Panther made it prone to overheating. It was enough for the radiators to clog with dust or fluff, and the temperature went into the red zone. The carburetor, a complex, capricious system, sensitive to dust, to fuel quality, which could present surprises in the cold. And most importantly, the very principle of operation. A gasoline engine, especially such a highly tuned one, is essentially a controlled explosion in the cylinders. High revolutions, high temperatures. It requires the most precise ratio of gasoline and air. Any failure leads to a drop in power, detonation, that is, destructive micro-explosions in the cylinders, burning of pistons. The actual engine life at the front often dropped to 100 to 150 hours. And then a major overhaul which was extremely difficult in field conditions. The tank was incapacitated not by a shell, but by a sick heart. Now let's look at logistics. Gasoline is a flammable liquid with high evaporation. A bullet or shell hitting a fuel tank or the engine often meant an instant, bright, torch-like fire, from which it was almost impossible for the crew to escape. And gasoline is consumed in large quantities. The specific fuel consumption of the Maybach, 230 to 240 grams per horsepower per hour. Multiply by 700 horsepower by hours of operation, you get monstrous volumes. Every German tank division dragged behind it a long, vulnerable tail of fuel trucks, which were a prime target for partisans and aircraft. Tankers called them mobile bonfires. Without this tail, the steel predators turned into immobile fortresses. Part 3. The Soviet response. A risky leap and the philosophy of survival. And what about the Soviet Union? This story is like a detective with elements of science fiction. In the late 20s and early 30s, the USSR had no tank engine industry of its own. There was an understanding that an engine was needed, a prospective one, a diesel. Why diesel? Because its advantages for military equipment were obvious even then. Efficiency, fire safety. Diesel fuel burns much worse than gasoline. Greater torque at low revs, which is important for a heavy vehicle. But creating a powerful, compact, high-speed tank diesel at that time was an incredibly difficult task. This was taken on by a team led by the brilliant designer Ivan Trashutin at the Kharkov locomotive plant. And they went all in. Instead of a conservative cast iron for the cylinder block, an aluminum alloy was chosen. This sharply reduced weight, but was a technological nightmare. Casting complex shapes from aluminum, ensuring strength, combating leaks. The fuel system, not a carburetor, but direct fuel injection by high-pressure pumps, fuel injection pump, a technology of jewel-like precision which is complex even today. For valves per cylinder, the Maybach had 2, for better efficiency. Displacement, a colossal 38.8 liters. The V-2 engine was born in agony. The first samples had a laughable engine life, sometimes less than 100 hours. Aluminum casting produced defects, fuel injection pumps were capricious, seals leaked. It was not the pinnacle of engineering thought, it was a bold, raw, but brilliant in concept project. And here is the key difference from the German approach. The Soviet state, in the person of the military and political leadership, consciously accepted this risk. They accepted the low resource, the high percentage of defects at first, because they saw the strategic goal, to obtain a fundamentally different, more advantageous unit for a protracted war. The V-2 was not better in the German sense of the word, perfectly balanced, brought to condition. It was more suitable. Its philosophy, degradation without catastrophe. Yes, over time power could drop, oil consumption could increase. But it kept working. even with a clogged radiator on poor fuel with worn pumps. It endured. It was tenacious like the country that created it. And now about the numbers. Specific fuel consumption. About 160 to 170 grams per horsepower per hour. Almost a third less than the Maybach. This meant that a Soviet tank brigade could travel significantly further on one refueling. It required fewer escort trucks. Autonomy, a terrible word for an enemy commander. And fire safety, these are saved lives. The crew of the T-34 had a much greater chance of surviving a penetration of the fuel tanks or a hit in the engine compartment. The vehicle often didn't burn, which means the possibility of repairing it and returning it to service. In a war of attrition, this is not just a plus, it's a defining factor. Part 4. System deadlock. Why Germany couldn't turn the tide. The most interesting part begins when the Germans themselves understood everything. Already in 1941, after encountering the T-34s and KVs, German tankers and engineers unanimously spoke about the advantages of diesel. There were reports, recommendations, memos. It would seem a country with colossal engineering potential should have mobilized and given an answer. But that didn't happen. Why? Here we run into what can be called systemic rigidity or bureaucratic inertia. By that time, a powerful symbiosis had formed. The Army Weapons Office, more precisely, its 6th Department, responsible for motorization, and the Maybach Company. It was its own universe with its own standards, connections, funding flows. Switching to diesel meant not just changing drawings at Maybach factories. It meant breaking the entire production chain. Different machine tools, different materials like aluminum alloys, different subcontractors for fuel injection equipment. It meant admitting that the previous course was mistaken, something bureaucracy always does with great reluctance. There were attempts. A personal order from Hitler appeared in 1942. Develop a tank diesel. But here too, the German maximalism manifested itself. They couldn't just copy a successful idea. No, they decided to create not just a diesel, but a masterpiece surpassing everything. For example, the SLA 16 project from Porsche. An X-shaped 16-cylinder diesel with air cooling. Technically sophisticated, incredibly complex, with a bunch of bells and whistles. But under the conditions of 1944, when factories were being bombed, skilled workers were lacking, and resources were scarce, such an engine was impossible not only to mass produce, but even to properly bring to completion. The Germans continued to think in terms of the ideal engineering solution. The USSR thought in terms of a solution acceptable for war. And under conditions of total conflict, the second approach won. They often say, Germany didn't have diesel fuel. That's a myth. There was enough diesel fuel in the Reich. The problem was different. The entire logistical infrastructure, from refineries tuned to produce aviation and automotive gasoline, to the system of depots, tankers, instructions for rear services, was tailored for gasoline. Rebuilding this giant machine in wartime was tantamount to chaos. It was easier to continue producing gasoline and hope for a wonder weapon. Part 5. Lessons of History. What does this mean for us today? So what do we have in the end? The story of Maybach versus V-2 is not a debate of gasoline versus diesel. It is a fundamental clash of two philosophies. On one side, the philosophy of quality, the ideal technological superiority, designed for a short, victorious dash. This is the philosophy of the sword. Beautiful, sharp, deadly, but requiring a skilled fencer and careful handling. On the other side, the philosophy of survivability, adequacy, maintainability, and mass production, designed for a long, exhausting struggle. This is the philosophy of the sturdy shovel. You can dig a trench with it, use it in battle, and if it breaks, repair it in the field. Germany, in the form of the Maybach, created the pinnacle of the first philosophy. But the war presented the demands of the second. And it turned out that it's impossible to rebuild in time when your system, both technical and bureaucratic, is too deeply rooted in old paradigms. This lesson is relevant even now in any sphere. Business, technology, management. You can create a perfect, elite product, but if the market demands simplicity, reliability, and scale, you will lose. You can be the best in your narrow niche, but if the world changes and you are not ready to sacrifice your maximalism for the sake of adequacy, You will face the fate of the tigers in the mud near Kursk or in the snows near Stalingrad. Victory in the Great Patriotic War was forged by millions of factors: the courage of soldiers, the labor of the home front, the talent of commanders. But in this victory, there is also a share of the modest, smoky, perpetually unfinished, but incredibly tenacious V-2 engine. And there is a share of the tragedy of the brilliant, but belated and clumsy German engineering genius embodied in the Maybach. So that's the story, friends. It makes you think, doesn't it? How often do we ourselves in life cling to the perfect solution, losing sight of the fact that we just need something working here and now? History is the best teacher, and this technical drama is a vivid confirmation of that. And what do you think about this? Maybe I'm wrong about something? Maybe you've heard other facts? Be sure to write in the comments. Let's discuss. Discussions on our channel are always on fire. And if you enjoyed this deep dive, if you want us to continue unpacking such pivotal but often forgotten moments of history and technology, hit the thumbs up and subscribe to the channel. Your support and your opinion are what we work for. There are many more untold stories ahead. Stay with us,